going through the book as well as working on the implementations, right? This would be the implementation of pretty much on the reinforcement side, chapter 9,
Hmm.
the trading one. So what I did was I just tried to pull a different data set and try to train and pretty much implement everything myself or using Google Colab. Not the
Right.
smartest of things because obviously it took a really long time for the training on Colab. I think, um,
Yeah.
yeah, but
Yeah.
other
Also,
than
I mean,
that,
I think the code for this is slightly tricky, as in, I'm
yeah,
not sure whether you're using it for or doing it for just call option,
yeah,
or you're also doing it for some exotic stuff. But yeah, I mean, even for call option, if you try to apply just reinforcement learning, and even if you go for the most vanilla neural network, it might be time taking in terms of like coding. So I agree. Yep,
yeah,
it
yeah.
will take some time.
Yeah, it took some time, but then I then just in terms of update as well. And then the second one, which was pretty close to what I was really interested in, is the deep hashing. Well, the derivatives hashing one really.
Hmm.
And one thing I wanted your take on was in the implementation. What happens is, well, the first part is I tried to work through the implementation, and then I hit some TensorFlow version 1, version 2 issues in some parts of the code implementation that I was trying to sort through. But
Right.
the key thing that I was actually interested on was incorporation of transaction costs, because in the
Yeah,
implementation, this is just a way of extending out, like you said you wanted us
makes
to.
sense. Yeah.
So because I seen that in the implementation, they had not actually considered transaction costs; they were taken as zero. So what I did
Hmm.
was I just read through a couple of, I think it's old papers that you probably knew, like Leland, that characterizes the liquidity component, liquidity,
Hmm.
like that takes illiquidity pretty much as a transaction cost. And so
Right. Right.
that's sort of the way I was trying to see how easily I could try to implement that just as an add-on to like the variations that were done in moneyness and volatility in that part, just to see what I could come up with. So that's pretty much sort of the angle I've been taking on. So I've been balancing that with pretty much trying to understand how it's actually mathematically written out. So the understanding that I got was pretty much that given the fact that we're comparing this with the Black Scholes model, so
Hmm.
we could pretty much incorporate that illiquidity, I'll call it a premium, within the volatility that's used in
Hmm.
the Black Scholes, and then also incorporate it within the model, within the reinforcement learning model, and see how
Hmm.
those two uh, actually perform. I must say though, to be honest, I'm at the point where I'm working to understand the two, and if there's any guidelines that you might have, I'd appreciate that as well.
Yeah, I think you're taking the right approach. Uh, what I would suggest is like there are two ways you can approach this problem statement. One would be, I mean, the one that you are already doing it, which is I mean, writing the code from scratch. I mean, just doing it for the call option and doing it from scratch. Another thing is, as you mentioned, doing the variant of whatever is already there. So use the same code
Yes.
and try to do the variants, as in include transaction cost, and try to get it done for other exotic options. And in terms of like change in the code, I think there might be some quick hack that you can do. I mean, I can just give you some hint. Let me open the book. So in case you have the book with you, I can tell you what exactly has to be done.
Okay. This is yeah.
Yeah. And then you can take it from there. Let me open the book as well.
I have the book. Huh?
Yeah. I'm trying to open the soft copy. Yeah, so if you go to the equation on page 317, right, where we have this PNL as a function of
Yes,
the option payoff and the delta, and
and
then
this and the transaction
minus
cost.
transaction
Yes.
cost, right? Exactly.
So
So that is where you can
yeah.
incorporate the transaction cost. And in terms of the code chain, that it might not be a significant code chain. You can just
Yes.
assume the transaction cost may be uh, let's say 25 cents for $1 traded and things like that. I mean, you can make your own assumption, and then you can put it in the reinforcement learning framework or the same code that I have in the book, and you can see the results, how the numbers and the final output vary. So that can be approach one. And the second approach can be, you can try it for exotic options as well. So when you're going for exotic options, in this equation, the ZT and the delta, I mean, all these two things might change. So for example, the if you take Asian option, so in case of Asian option, the final payoff would be a function of the average of, let's say, the average
previous
of the
cuts.
spot, or the average of the average of the previous prices, right? And that is how you can modify this ZT and keep everything else same, and see how the final output and the final conclusion looks like. So that would be my suggestion, and feel free to add your own exploration and add your own input to the analysis or the project that you guys are doing. Make sense?
All right. Yeah. Thank you for that.
Yeah.
And then just a second one. Out of interest. Well, there's two other points as well. I came across this very interesting. I don't know whether you'd probably worked on it or seen it. This it's called a slide. It's some paper that some implementation that came out of some university that's pretty much providing an easier way to implement some of the models on CPUs rather than GPUs. I don't know whether you'd
What's it? What's the name? What do you mention?
It's called
What is the name you
Slide.
mentioned?
Slide. SLIDE.
Okay, maybe. Yeah,
I tried to look at
heard.
it. I just wanted to find out, because I tried to look at it when I was trying to get some of the stuff working, and I thought it would be a lot easier. So I was just mentioning that, asking about
Yeah,
that. Yeah.
haven't heard of it, to be frank, but what I know about is, like, there are a couple of reinforcement learning based libraries, so very similar to what you have for supervised learning. So for example, for supervised learning, you have scikit-learn, right? So where the entire model is like in encapsulated in a few lines of code, right? And there are similar kind of things for reinforcement learning, but it becomes slightly tricky because you need to make quite a lot of customization when you're working in the reinforcement learning space. And then it's better to have the code in the form of classes and in the form of what it's there in the book. Because if you try and go for those kind of libraries, then it's the customization becomes kind of difficult. But having said that, you can always explore those libraries and see how it looks like with the current problem statement. And then again, you have to design your own in the in if you're using those kind of libraries, you have to see how you can embed all the information, as in your reward function, your state variables, and your action when you're using reinforcement learning. And that I tried doing it. I remember there was one library I was using, but I found it kind of difficult to customize it to the the reward function that I was trying to use. So I kind of avoided doing that. But feel free to explore.
No, I tried looking at the code implementation that you're gracious to give us access to using GitHub, and try to look at how to probably use the two. And that's why I was asking, because I was like, okay, this is probably a bit beyond me right now. So yes.
Yeah.
Thank you. I think from my side, that's about it. I mean, then the last one was just I think it was the Fields Institute conference that I saw you on as well, that they were talking about the implementation. I think that was quite interesting as well. I was just mentioning that.
Yeah, I mean, the work that they have done, I think they have got some award or something from the risk.net. And what essentially my understanding was, like, it's pretty interesting. And they have used deep neural network for option pricing. So basically they take supervised learning, train the model, take all the inputs in the market price. And once the model is trained, it can be used for a lot of new exotic options. But the only problem that I've thought, or I don't know whether you were in the conference or not, but I asked
I was
one
there.
question.
I actually heard your question. Yes.
Okay, then you know everything in detail, right? I mean, the only thing I'm apprehensive about in that case is like all the corner cases, because there are different kinds of options. I don't know, once the model is trained on one particular kind of model or one particular kind of option, whether it will be able to price a new or a different kind of option with perfection. So that is where there might be some risk, especially if you're trying to use those kind of deep neural network for pricing on the trading desk. there might be an issue. But that was my only concern. But yeah, I mean, it's something which is cutting edge, and going forward, I see a lot of adoption of deep learning for these kind of use cases.
Yeah, no, thank you very much. I think I also just
Yeah,
found the fact that how quick they were saying that it's easy for you to actually derive a price eventually when you're using it on desk. I
yeah.
think that was one of the key places. I
Yeah,
think this is
it's
really
it's really
interesting.
good for the those kind of processes in the bank which are like overnight batch processes which take quite a lot of time, and even if there is slight difference or slight error in terms of pricing, it is not of a very significant impact for the bank, right? But if you start using those kind of models for trading desk and you're quoting price to, let's say, other broker using those models, there might be like a big profit and loss involved, or there might be some risk there. That is what I feel.
Okay, thank you very much. I think
Yeah,
from my side at the moment, that's what I had. I can pass it on to
good
either
stuff.
Brian or
Yeah,
Iran. Thank you.
good stuff.
So, Arium, what the approach we I took, and then Zach's hopping on here, but I'm a big research guy, so I've been just honestly blasting the internet trying to figure out what does interpretability mean and kind of what
Hmm.
work's already been done out there.
Right.
And what I've settled on, and Zach, feel free to chime in here on some of the stuff I've sent over to you, and hopefully you take a look at it. But a visualization is super helpful. Some kind of web platform that you can see loss, reward over time.
Hmm.
So what I've found is, I'm trying to share my screen here. Quick little visualization to show you. So someone basically trained a network, a model here, as you can see. And as you can see, you have the reward over time, and then you
Hmm.
have the episode length over time. But I think what's more important is
Hmm.
this visualization here with the blocks moving. So this is
Right.
basically trained on a game where you have 4 actions. You have left, right, up, and down. And each of those actions has an associated reward, right? So in every decision point, we have a visualization here of what is. I mean, you can see the arrows a little screwed up here, but the gist is pretty understandable. How it's highlighting which action is deriving the most reward. And then this is your
Hmm.
cumulative value, over the training space. So this is kind of something that can be, I'm assuming, can be adjusted right to the trading space. So your actions obviously buy, sell, hold. The rewards are P&L, right? And your state is 1, 2, or 3. Basically, we just hard code buy, sell, hold into state 1, 2, or 3. And then kind of track reward. Again, this is P&L over time, and kind of go from there.
Hmm.
So this is kind of my idea. It's still very early, but it's better to
Hmm.
have the end goal and then work backwards, in my opinion. Wanted to hear your thoughts about kind of taking this approach.
Yeah, I mean, according to me, the approach looks good, and it is very similar to even what I was proposing. If you go to the second bullet point of the second project, and that is something related to visualization that you guys have put. So what I was proposing is that in your example, let me see the screen.
Yep.
Can you share the screen again?
Yep. There you go.
Yeah, so in your example, in our case, for example, if you're taking the trading strategy and so we know the action, reward, and state in our case, right? So the action is buy, sell, and hold.
Yep.
Reward would be the P&L that you're making, and the state would be state you can define in uh, you can customize it in any way. I mean, you can use the volume, or you can use the historical change, or the change in the price of the stock in last 2 days or 3 days, something like that. And depending on that, you can see what is the model doing. So for example, let's say if the price goes down by 2% or 3%, what is the action, whether it's buy, sell, or hold. And that is something you can see, and you can then generalize one hypothesis, or you can create one hypothesis that, okay, this is what happens in case of 2% drop in the stock price, or 3% increase in the stock price in general, after the model is trained. So it's a really good way to understand, or to interpret the reinforcement learning model. Uh, Yeah, and then you can also think about some other uh, interpretability related stuff, very similar to what you do for supervised learning. So for example, you change or tweak your state variable, let's say by 1 or 2%, and see the sensitivity of that impact on the action and reward. And that can also be used to understand what's happening. And then another point can be that you can try to relate or correlate it with some of the well understood algorithms. So for example, there is something like French pharma model, or there are a couple of technical analysis which is done, and see, and you can check whether this reinforcement learning algorithm is doing something which is similar to uh, some uh, some models which are well tried and tested, right? So that is another approach that you can use. But yeah, I mean, I kind of like it, and try to see whether you can what you can do is you can use the same code that I have from the book, or feel free to like take any other code and see whether you can customize it for this UI that you are showing. And I
Yeah,
think that
that's
would be
pretty
really
much
usely. Yeah.
that's pretty much what we were gonna do. We're basically gonna take, obviously you've done 90% of the heavy lifting, and we kind of
Yeah.
have to come in and polish off the other 10. I
Yeah.
guess that's an interesting point. Basically, so you're saying not only internal interpretability, meaning within the model, right? But then take the model and compare it then compare it to something else, right? So out of model comparison.
Yeah, I mean, what I'm trying to say here is that you should try to figure out a theory or some conclusion which is kind of concrete. I mean, of course, and there might be a lot of conclusion that might come out of this visualization. But what I am thinking about is that let's try to come up with some hypothesis or theory that, okay, with 2% increase, this is what we see, 3%, this is what we see. And as compared to some of the well-known methods and models, this is how it behaves, whether it is aligned with some of the well-known methods or models, or whether it's not. So that is something you guys can check.
So are we, just to clarify the hypothesis point, are we basically investigating whether the model's sensitivity to a 2% change is greater than or less than that of a well-known model?
I mean, there are two aspects of it. One is just forget about other models. Just take this model and see that what's happening with 1%, 2%, 3%. You can make some kind of heat map and see what's happening to the reward and action with 1% increase, 2% increase, 3% increase, so on and so forth, right? So forget about other models. Just do it in isolation, right? And see whether you can come up with some theory or hypothesis. And the second step would be compare it with something which is well known. So for example, take pharma French model or some well-known model, and see that what happens or what is the output of that particular model if you increase the stock price by 1%, whether it's asking or whether the conclusion is to buy or sell, and whether your reinforcement learning model is doing the same thing. So see whether these are kind of matching or not, and then you might be able to relate your reinforcement learning model with something which is well known. Or that can also happen in some limited set of inputs. So for example, when the stock price increases between 2% to 5%, the model behaves very similar to some well-known model, but it's not behaving in some other region or other regimes, right?
Okay.
So some kind of hypothesis, some kind of some logic is something which is needed, and that is what is missing most of the times when we are using things like reinforcement learning. That there has to be some theory, hypothesis when we are working on these kind of artificial neural network or reinforcement learning models, especially.
Understood. So I wanted to ask.
You need to come up with some kind of story, basically, that okay, this is what reinforcement learning model is doing, and this is how it is compared to other well-known models and methodologies.
Understood. I wanted to ask, so specifically, right, so we have a DNN nested inside our reinforcement learning algorithm. Is there value in doing a full-blown interpretation of the deep neural network, which maps action to reward, or is that not necessary and just focus on the RL part of it?
Yeah, you can try that as well. I mean, there are very many well-known models or methodology to interpret your artificial neural network. One simple thing that I know is that you convert it into some kind of linear function. So you take the input that goes to the artificial neural network, and take the output that comes out of the artificial neural network, plug it into some kind of linear regression model or a simple model which is easily explainable, and see whether it's making
Yeah.
sense or not, or whether you are able to do some kind of interpretation out of it or not. And that would be like the third part of this project. So first part is just trying to make sense of this reinforcement learning model in isolation. The second part would be comparing it to some well-known models. And third part would be trying to understand what's happening inside the artificial neural network by converting into some simpler models. Make sense?
Absolutely. Yeah, I was just going to add, and then obviously the loss of your DNN over epoch would be another form of interpreting what's going on there.
Yeah, I mean, there might be, you might see quite a lot of volatility with the number of epoch or with the number of parameters or layers or nodes. But the idea would be to come up with something which is not changing much. So idea would be to have some kind of final conclusion or a reach of, I mean, some kind of conclusion or convergence basically whenever you're trading or changing layers or nodes as such in your artificial neural network.
Okay, perfect. I think we have work cut out for a little bit here. I just wanted to ask about the UI implementation. Is there a preference there, or is it kind of whatever works?
I don't, yeah, I mean, I'm not so particular about UI as such. I mean, this particular UI that you're showing is pretty good. What I would uh, like is some kind of heat map. So for example, this square that you are seeing, if you maybe make it bigger and with 2% change in uh, let's say the stock price, historical stock price, what's happening. So you will see some kind of heat map, whether it's going for buy, sell, or hold, with different changes in the stock price, which is the state variable. And that might give you some kind of intuition that, okay, if it's the stock price is changing in this range, this is what algorithm is doing. So I think that would be good enough, and don't want like fancy UI. I just need, or it would be better to just have some kind of story coming out of your model in the end. Make sense?
Yes, absolutely. Thank you very much for
Let's focus on like, yeah, let's focus on getting the story right and the mathematical side of it rather than like UI and making it more fancy. That's my take. And in case you're interested in like making UI more fancy, feel free. But my take would be like, let's do the basic right and then move on to the UI part.
I totally agree. I'm no UI expert. Just wanted to hear your take on what you want this thing to relatively look like.
Yeah.
Thanks, Brian.
Hi, Harry.
Hi, Yaran.
Hi, I just want to update you like on the on my proposed timeline of the project, maybe because I haven't find much time to focus on the project, and I don't want to waste your time as well.
Right.
Potentially, I think I could start working on the project starting June if the timeline is okay with you.
It should be fine. And you can also maybe take like baby steps, right? What you can do is you can just start with, so if you, so you're doing project 3, which is converting data into equation, right?
Yeah.
So you can maybe take the case study that I have in the book, which is related to pricing call option, right? And you can take the data as in all the input that goes to the call option and the output as in which is the price, and try to plug it in the API that I've sent to you, and see whether it's giving out some equation or not. So you can start with that, and then you can move on to some complex stuff. So with that, you might not have to like spend quite a lot of time, and then you can see whether it's giving something concrete or not. That is how you can proceed, according to me.
Okay.
But yeah, I mean,
I just,
June should be fine. But to be frank, that is some, yeah, that is one of the most interesting project that I have seen. Because I have not worked on that at all, but the idea is very, very intuitive.
Yeah.
And so the idea is that, okay, I mean, rather than coming up with some stochastic equation, if you can convert the data into equation, there's an automated way of converting data into equation that'll be really good for like everyone. So you can start with like some basic basic case study, and then you can move on to any complex one. So for example, transaction costs and all. But I think the timelines, according to me, June is fine. June should be fine.
Yeah, and anyway, you do have access to one or two, or at least 2 or 3 undergraduates. So I know that you're finishing your, it's in a semester, but you could,
Yeah, I have.
but
Yeah, I
part-time.
just have also some other stuff going on at the same time.
Yeah.
That's why I'm proposing maybe because starting June I will have like much more time because
But
right now it's
do you have
love.
no, that's okay.
We-
Do you have an undergraduate working with you or not?
We decided to share the resources.
Okay,
but
that's fine. That's fine.
But for me, like the project is more mathematical. But most of the undergraduates are coming from either computer science. Well, yeah, most computer science. So.
Okay, let me see if I get you someone. Arium, thank you
I
very much
think-
for your time. I know that you're busy, so we'll get cranking on that and we'll see you again.
Thank you, guys. Thank you very much.
Okay.
Have a nice day.
Okay.
Yeah.
Thank you.
Bye.
Bye.